Now coming to the fourth quantum number, that is the spin quantum number. In the year 1925, Gauss-Smith and Uhlenbeck suggested that an electron, while moving in an orbital around the nucleus, also rotates or spins about its own axis either in a clockwise or anti-clockwise direction. This spinning of electron about its own axis can also be called as self-rotation. It means, as we all know, that the electron is revolving around the nucleus. Electron की इस movement के अलावा, यानी its movement around the nucleus, apart from this movement, the electron is also spinning about its own axis. As we can see here, that this spinning of electron about its own axis can be in a clockwise direction or it can be in the anti-clockwise direction, as we have shown it with the plus half or minus half. Hence we can say that the opposite magnetic fields are generated by the clockwise and the anti-clockwise spins of electrons. And this spin motion is responsible for the doublet line structure. So what is this doublet line structure, or how we came to know about the spin quantum number? For example, let's talk about the alkali metal. हमें पता है that the alkali metal have one electron in their outermost shell. If we study the emission line spectrum of this electron, emission line spectrum कैसे study होगा? If the electron jumps from a higher energy state to the ground state, then the emission line spectrum will be obtained because of the radiation emitted by the electron from coming from higher state to the lower state. Now when the spectra was observed by using a high resolving power spectrometer, each line in the spectrum was found to consist of pair of lines. These pair of lines were called as the doublet line structure. This doublet line structure is different from the fine structure or the multiple structure of hydrogen, because in the doublet line structure the lines are widely separated from each other, while those of the fine structure were closely spaced together. So this doublet line structure confirms that the electron is spinning about its own axis, and this spinning or self-rotation is either clockwise or anti-clockwise, जिसको हमने plus half या minus half से show किया. So now finally, after completing the four quantum numbers, let's have a comparison between these four quantum numbers. जैसे कि हम start में कह चुके हैं that a single quantum number is not enough to completely describe an electron. For the complete description of an electron, we had a set of integral numbers called the quantum numbers. As a summary or as a conclusion, we can see that the principal quantum number tells us the distance from the nucleus. Greater the value of n, greater will be the distance of electron from the nucleus. L, the azimuthal quantum number, tells us the shape of the orbital. The magnetic quantum number, that is small m, tells us the orientation in space. इसीलिए हम magnetic quantum number को orientation quantum number भी कह चुके हैं. Whereas the last one, that is the spin quantum number, tells us the electron spin, either clockwise or it is in anti-clockwise direction. So this is to have an idea or to have a summary or conclusion about the four quantum numbers. Here is another table. In the first column, we have the values for n, that is the principal quantum number. Next we have the azimuthal quantum number, and then the orbitals. Then the values of the magnetic quantum number and the spin quantum number here. In the last columns, we have the number of electrons in the subshells and lastly, the number of electrons in the shells. और इस टेबल को देख के हम आसानी से समझ सकते हैं that if the value of n is known, we can easily conclude and tell about the value of L. We can also tell the value of M and then the spin, that either plus half or minus half. And lastly, we can also calculate the number of electrons in the shell and in the subshell as well.